Hello everyone, this is part 3 of the lesson 10.4, Zero and Negative Exponents. Here we're going to simplify, but we're going to make sure that we write the expression at the end using only positive exponents. Okay, that's going to be very important to pay attention to. Starting with A, we have 6 times y to the negative fourth. Now I'm going to go ahead and change this just a tiny bit to remind you that this means 6 times y to the negative fourth. And I do this because I want you to notice that we have two different bases. Okay, 6 is one base, y is another. So the negative 4 is only applying to the y. So when I go ahead and simplify this expression, we only need to change the y. So 6 is going to remain the same times anytime I have a power with an exponent that's negative. Now that's going to become 1 over that very same power, except I will change the exponent. It will be the opposite. So this is negative 4. This becomes 4. Here I can still simplify this a little bit more. I'm going to go ahead and add a 1 for the denominator of 6 so that I can go ahead and multiply these two fractions. So that at the very end I have 6 times 1 is 6, and then divided by 1 times y to the fourth is y to the fourth. So this would be the way to simplify that expression. B, we have 8 to the negative squared times 8 to the seventh. Now here we're emphasizing that we have two different powers, two different bases. So here the negative exponent belongs to the 8, so this one is going to be changed. So anytime we have a negative exponent, we need to go ahead and write the reciprocal of that power. So it needs to become 1 over the same power, so the same base 8, but then instead of negative 2, we write the exponent positive 2. Okay, it's always going to be the opposite. Times 8 to the seventh, that's a positive exponent, so nothing happens to that. Here I'll do a similar thing like I did for the previous example, where I'm going to go ahead and add a 1 under the 8 to the seventh so that I end up with two fractions, and I'll go ahead and multiply the two fractions. So the top times the top, so that's going to be 1 times 8 to the seventh, that is going to be 8 to the seventh, divided by 8 squared times 1, that is going to be 8 squared. After that, I can go ahead and simplify this a little bit more, given that this is 8 squared, which equals 64. So I'll go ahead and write my final answer as 8 to the seventh over 64. Letter C, we have a quotient 8x cubed divided by 2x to the ninth. So let's go ahead and rewrite this as 8 times x cubed divided by 2 times x to the ninth. Here we could be a little bit creative with the 8. Do you know what 8 as a power of 2 is? That would be 2 to the third power, 2 cubed, because 2 times 2 is 4, times 2, that's 8. So if we wanted to, we could actually change that 8 and make it 2 to the third times x cubed divided by 2 times x to the ninth. This way, it would be very easy to tell that we are going to work with powers that have the very same base. We need to divide them, so we can keep the base 2 and subtract the exponents. 3 minus, there's no exponent here, so assume that it is 1. So 3 minus 1 times x to the 3 minus 9. 3 minus 9. So this is going to be equal to 2 squared times x to the negative 6. This is equal to 2 squared is 4 times x to the negative 6, I need to go ahead and rewrite that using a positive exponent. So this becomes a fraction, 1 over x to the positive 6. Make this for a fraction by putting a 1 under it, and go ahead and multiply those two fractions. So 4 times 4 times 1 is 4. 1 times x to the 6th is x to the 6th. And that would be my answer. Okay, I would like to come back here. Okay, so after this step, we said if you notice that 8 is the same thing as 2 cubed, then we could go ahead and apply the property for quotient. But sometimes we're not going to be able to do that. So let me just go ahead and rewrite this. 8 times x cubed divided by 2 times x to the 9th. The only thing to remember is that sometimes you could go ahead and simplify numbers. In this case, we have that 2 is dividing the 8. So that is going to give us a 4. So 4 times x to the, this is a quotient, so 3 minus 9. So this is going to be equal to 4 times x to the negative 6. And from here, we're going to get the same thing as we got before. So 4 times the reciprocal of this, because we have a negative exponent, so 1 over x to the positive 6th. We make this a fraction by putting a 1 under it, and we say 4 times 1 is 4, and 1 times x to the 6th is x to the 6th. Letter D, we have 3d to the negative 4th times 4d to the positive 4th. So let's go ahead and rewrite this. Let's go ahead and separate the two bases that we have here. This means 3 times d to the negative 4th times 4 times d to the 4th. Everything here is multiplying. So we have the commutative property that allows you to move those factors around. So I could rewrite this and say I have 3 times 4 and then times d to the negative 4 times d to the positive 4th. I'm going to go ahead and keep this 3 times 4 times, and I'll go ahead and take care of this product of two powers that have the same base. So I keep the base and I add the exponents, so negative 4 plus 4. This is equal to 3 times 4 times d to the 0. This is equal to 3 times 4 times, anytime I have a power with an exponent 0, that becomes 1. So 3 times 4 times 1. Now the last thing to do is to go ahead and multiply. 3 times 4 is 12, times 1, still 12. So that's my final answer. So make sure that you go ahead and watch this video a couple times until you make good sense of what it is that we are doing with the expressions, how we need to rewrite them in case we come across a negative exponent, and how we are simplifying.